From our previous video, we already learned what is queues. A queue is an ordered collection of items from which items may be deleted at one end called the front of the queue and into which items can be inserted at the other end called the rear of the queue. Queue is an abstract data type. A queue is called FIFO, that is, queue follows the rule FIFO, first inserted element will be deleted first. So, queue follows the rule FIFO, first in, first out. This thing we already learned in our previous video. Please consult our previous video. And also, we learned that there are four types of queue: linear queue, circular queue, T queues and priority queues. We already learned what is linear queue and what is the disadvantage of linear queue. That's why we have to learn circular queue. So, what is the disadvantage of linear queue? And to overcome that disadvantage, we have to learn circular queue. We already learned this thing in our previous video. Please consult our previous video. Today our topic is circular queue. What is circular queue? Here the array that holds the queue element is circular rather than linear. If the last element is occupied, a new value is inserted in the first element of the array. That is, when we reached at the last position of the array, start inserting from the beginning of the array. That is, from the first element of the array, provided the first position is empty. So, what is the initializing condition? Both rear and front are -1. Primitive operations of circular queue. First is empty, to check whether our queue is empty or not. Full, to check whether our queue is full or not. Insert, to insert some element into the queue. Remove, to remove or delete some element from the queue. So what is the data structure of queue? Data structure of circular queue is same as the data structure of the linear queue. First you have to write the keyword struct, then queue, and this is one integer array item. It can hold maximum number. Max is the number of elements that integer array holds. Then rear and front, two integer variable. Rear is the inserting end and front is the deleting end. And this queue is the object of this structure. Circular queue, how it works. See this example. This is our circular queue. This is the rear end, that is the inserting end, and this is the front end, that is the deleting end. We want to insert this element into this queue. And see, when the queue is empty, what is the initializing condition? Initializing condition is both rear and front are -1. Now start insertion. First, you have to insert 2. So, when you start insertion, make both rear and front as 0. I repeat, when start insertion, make both rear and front as 0. So, rear is 0, front is 0, insert 2. Now, you have to increase rear, insert the element. Increase rear, insert the element. Increase rear, insert the element. Increase rear and insert the element. In this case, see, now the queue is full. So what is the condition for full? Condition for full is that if rear plus 1 mod max equals to queue front, then we can say that queue is full. So what is the value of rear now? It is 4. 4 plus 1 means what? 4 plus 1 means 5. 5 mod max. 5 mod max. Max is what? Max is maximum number of element queue can hold. It is 5. So 5 mod 5. What is the remainder? Remainder is 0. Is equal to queue arrow front. What is the value of front? Front is the deleting end. So it is still 0. When the rear plus 1 mod max equals to front, then we can say the queue is full. So both are 0. So we can say the queue is full. So what is the full condition? Condition is if rear plus 1 mod max equals to queue arrow front, then we can say that queue is full. Deletion. So this is our rear end, this is front end, rear end is the inserting end and front end is the deleting end. When when the rear is max minus 1, then you have to start insertion from here because it is circular. So when rear equals to max minus 1, then rear becomes 0. But before that you have to delete some element from the queue. Queue follows which rule? FIFO rule. So first you have to delete 2. So front is 0. So delete 2, then increase front. Delete 4, increase front. Delete 8, increase front. So front is 3 now. Again I want to insert. When rear equals to max minus 1, then rear is 0. What is the inserting end? Inserting end is the rear end. So I start inserting from the beginning, that is when rear equals to 0. So start insertion. Again I want to insert. Say I want to insert. Rear is 0 now. I want to insert 14. Then I want to insert say 15. So first you have to increase rear, insert element. Increase rear, insert element. Now see the situation. Now the queue is full. So what is the condition for full? Here rear plus 1 mod max equals to front. See, rear means what? 2. 2 plus 1 means 3. 3 mod 5. Max is 5. I repeat, rear is 2. 2 plus 1 is 3. 3 mod 5 is 3. See what is the value of front? Front is also 3. I repeat, rear is 2. 2 plus 1 is 3. 3 mod 5 is 3. Front is 3. So what is the full condition for this queue? Always q arrow rear plus 1 mod max equals to q arrow front. See here also q arrow rear plus 1 mod max equals to q arrow front. So this is the condition for full. Remember that. Now I want to delete. So front end is the deleting end. What is the value of front now? It is 3. So delete 10, increase front. Delete 13, increase front. Now front is 4. Because it is circular, start deleting from the beginning. So when front equals to max minus 1, then front equals to 0. So start deleting front from the beginning. So front is 0 now. Delete 14, increase front. Delete 15, increase front. Delete 16. Now see, both the value rear and front are same. So when both rear and front are same, then the queue is empty. So make both front and rear as -1. So if q arrow front equals to q arrow rear, then make both q arrow front and q arrow rear as -1, and that is the empty condition. So what is the full condition? When q arrow rear plus 1 mod max equals to q arrow front, that is the full condition. And which one is the empty condition? Empty condition is when q arrow front equals to q arrow rear, then make both front and rear as -1. So empty condition is both the value front and rear as -1. So what is the condition for empty? This is the rear end, that is the inserting end. This is the front end, that is the deleting end. When the value of rear and front both are -1, we can say that our queue is empty. So, the function empty for circular queue. If the queue is empty, it returns 1. If the queue is not empty, it returns 0. So, return type is an integer. Function name is empty. We are passing the address of the queue. So, struct queue star queue. Now, if the front is -1, obviously then rear is also -1. So, you have to check if the front is -1, then we can say the queue is empty, return 1, otherwise return 0. So, this is the function for empty for circular queue. Task is to try to write full function by your own. Condition for full. First, when the queue is empty, both rear and front are -1. Rear end is the inserting end and front end is the deleting end. First, start insertion. First, make rear as 0, front as 0, insert the first element. Increase rear, insert element. In this way, you have to insert. Increase rear, insert element. Now see, in this situation, queue is full. So, what is the condition for full? Condition for full is when rear plus 1 mod max equals to front. So, rear is what? Rear is now 4. So, rear plus 1 is 5. What is max? Max is total number of element in the queue. Okay? Means queue can hold max number of elements. So, it is 5. So, rear plus 1 mod max. Mod means remainder. Okay. Is equal to 5 mod 5, that is 0. What is the front value? Front is the deleting end. No deletion is done yet. So, front is 0. So, when rear plus 1 mod max is equal to 0 and front is 0 means when both are equal, then we can say that queue is full. So, the queue is full. Now, see this case. Now queue is full. So, the condition is when rear plus 1 mod max equals to queue front. Okay. Now, I start deletion. Which one is the deleting end? Front end is the deleting end. So, delete 2. Delete 2. Increase front. Front is 1. Delete 4. Increase front. Front is 2. Delete 8. Increase front. Front is 3. In this situation, we want to insert again. Inserting end is the rear end. So, because it is circular, we start insertion from the beginning. That is, if rear equal to max minus 1, what is the last value of rear? It is 4. That is max minus 1. Then start insertion from the beginning. So, I start inserting from the beginning. So, I insert 14. So, rear is now 0. Insert 14. Now, increase rear, insert next element. Increase rear, insert next element. Now see, queue is again full. So, what is the condition for full? Condition for full is here. See, here rear is what? Rear is 2. So, rear plus 1, it is 3. What is the value of front? Front is 3. Okay. So, formula is rear plus 1 mod max is equal to front. If it is true, if this equals to this, then we can say Q is full. So rear, what is max? Max is 5. So now see, rear plus 1 is 3. 3 mod max. So 3 mod 5, okay, is equals to front. Is this true? So 3 mod 5 means 3. What is the value of front? Front is also 3. So now the Q is full. So what is the condition always? What is the condition for full? Full is rear plus 1 mod max equals to front. Because both rear and front are the element of the Q structure, are the variable of the Q structure. So to access this, you have to use Q arrow. Okay, because we are passing in our function, we are passing the address of the Q. So to access rear and front, you have to use Q arrow. So this is the condition for Q full. Okay, so what is the condition for full? Here, if the Q is full, it returns 1, this function returns 1. If the Q is not full, this function returns 0. So return type is an integer. So return type is integer. Function name is full. Here we are also passing the address of the Q structure, this Q structure. Okay. Now we already learned what is the condition for full. If Q arrow rear plus 1 mod max is equals to Q arrow front, then we can say Q is full, return 1, else return 0. Because both rear and front are the variable of this Q structure, to access this you have to use Q arrow operator. So you have to write Q arrow because we are passing the address of the Q. And if the Q is full, it returns 1, otherwise returns 0. Insertion. Initially, when the Q is empty, both rear and front are -1. Okay. So, when we start insertion, make both rear and front equal and both at 0. Then start insertion. Okay. So, what is the initial condition when Q arrow front is equals to -1? Means when the Q is empty. Both are -1, but you can check only one. If Q arrow front equals to -1, then make both equal, Q arrow front equals to Q arrow rear. This is the empty condition for insertion. Okay. Now, after that you have to increase rear, insert element, increase rear, insert element. Okay. So, what is that formula? Formula is increase rear, insert element. So, first when the value of rear is 0, next value is rear is 1, next value is rear 2, next 3, next 4. So, it is, say first is 0. So, what is the value of Q arrow rear? It is 0. Okay. So, rear is 0. Okay. So, rear plus 1 mod max. Rear plus 1 mod max is equal to what? 1 mod max. Max is 5. Okay. So, here max is 5. So, 1 mod max means what? It is 1. Okay. So, next value of rear is 1. Okay. I repeat, rear is 0. First time max is 5. So, rear plus 1 mod max equals to 1 mod 5, it is 1. Next value of rear is rear plus 1 means it is 2 mod 5. So, the result is 2. So, next time rear is 2. Next time it is 2 plus 1 means 3 mod 5. So, it is 3. Okay. In this way it will continue. Now, when it is max minus 1 means when the value of rear is 4, then we start insertion from the 0. See, just increase there. Now, the Q is full. Now, delete some element from the Q. If rear equals to max minus 1, we have to start insertion from the 0th item. Okay. Before that, you have to delete something. delete some element from the queue by the front end. Now start insertion. Now see, when the rear is max minus 1, now the rear is max minus 1, so start insertion from the 0th element. So start inserting 14, then 15 in this way. So this case, when the rear is 4, okay. So rear plus 1 is what? 5. So what is the formula? Formula is next rear is rear plus 1 mod max. Next rear is rear plus 1 mod max, 5 mod 5, that is 0. That is 0. So what is the formula? Normally we increase rear, insert element, and when the rear is max minus 1, it is 0. So the formula is next rear is rear plus 1 mod max. Normally rear plus 1, if it is 0, 0 plus 1 mod max means that this is 1. Then 1 plus 1 mod max means this is 2. Then 2 plus 1 mod max means this is 3. But when the rear is 4 here, then 4 plus 1 mod max means 5 mod 5, that is 0. So when the rear is 4, then it start insertion from the 0th element. Now after that, you have to insert that particular element which you want to insert. Say the element is x. So item 0 is rear 0. Item 1 when the rear is 1. Item 2 when the rear is 2. So I can say that at the location item rear, you have to insert your element x. I repeat, say I want to insert 8 here. Okay. So what is the value of rear here? It is 2. So at item 2, that is item rear, I want to insert 8. 8 is x. Okay. I repeat, rear is 2, item rear, that is item 2 means item rear, I want to insert x. Okay. So in this way, this circular queue insertion works. Now see the code. So the function QInsert. Okay. So this is our function QInsert. Function name is QInsert. Here I am passing the address of the queue structure, this queue structure, and the element which I want to insert. If the queue is already full, then it is impossible to insert further any new element into the queue. So first call the full function. This full function, we already learned how to write full function for circular queue. Call the full function by passing the address of the queue structure, and see here we are passing the address, and if that function returns 1 means our queue is full, then it is impossible to insert. Otherwise you can insert. So call the function full. If that function returns 1, then there is one printf statement, it is impossible to insert, then end of the program. Otherwise, we already learned what is the condition for insertion. QArrow rear equals to QArrow rear plus 1 mod max. We already see how rear works. Okay. So when increase rear insert element in this way, and when rear is max minus 1, then we start insertion from the 0th element. This is the calculation. After that, you have to insert that particular element, means this x, to that position where rear points. So item rear is equals to x. So all these variable rear, item, front, all are in the elements of variable or elements of the queue structure. So to access these elements, you have to use arrow operator, because we are passing the address of the queue structure. So see Q arrow rear in this way. Now another condition we already learned, that when queue is empty, then front is minus 1, also rear is minus 1. So you have to check whether front and rear are minus 1, or you can also write just front is minus 1. Then you have to start insertion, then make both rear and front equal. Okay. So this is the condition for QInsert. This is the function for QInsert. Now your task is to try to write deletion function or QDelete function by your own. Now QRemove or QDelete. Say our queue is full, we have to delete. So what is the deletion end or deleting end? It is front end. So from this end you have to delete. So front is 0 because when the queue is empty, both rear and front was -1. When we start insertion, make front as 0, but no element is deleted yet, front is still 0. So we start deletion from the 0th element. Okay. So first you have to delete the element, then increase front. Delete the element, increase front. Delete the element, increase front. In this way. And when it is max -1, then start deletion from the 0th element. Okay. So when it is max -1, then start deletion from the 0th element. See here, in this situation, there is single element in the queue, and see both front and rear both are -1, sorry, both are 4. So after deletion, make both front and rear as -1. I repeat, here in this situation, front is 4. What is the value of rear here? See, rear is also 4. So after deletion, queue become empty. If the queue becomes empty, then what is the empty condition? Make both rear and front as -1. So see the code. First, delete that particular element which is pointed by front. So item front. So when front is 0, it is item 0. When front is 1, it is item 1. So we can write item front. So the element pointed by front will be first stored, the value of that element pointed by front will be stored in the variable y, and we return the deleted element, return y. Now this case is when rear equals to front, means this is the case for single element. When there is single element, means when rear equals to front, means there is single element, this case. Then after deletion, queue is empty. After deletion, queue is empty. So make both front and rear as -1. Otherwise, you have to increase front and insert element. So increase front, insert element. First time, what is the value of front? Front is 0. So front plus 1. Front plus 1 is 1. So front plus 1 mod max. Mod max means what? Max is 5. Front plus 1 mod max is 1. Mod 5, it is 1. Next time, front plus 1 mod max is front plus 1. 1 plus 1 means 2. 2 mod 5 means it is 2. In this way, front will increase. But when front equals to 4, then we start deletion from the beginning element, from the starting element. So front is 4. So front plus 1, it is 5. So 5 mod 5, it is 0. So this is the formula. Q arrow front, next front equals to Q arrow front plus 1 mod max. So next front equal to previous front plus 1 mod max. Max is 5. Previous front, in this case it is 4. So 4 plus 1, it is 5. 5 mod 5, it is 0. First increase front in this way, and when it is 4, then it start deletion from the 0th element. So this is the required coding. Now see the code. Before that, after deletion C, make both rear and front, max minus 1. So after deletion, make both rear and front as minus 1. Now coding for QRemove or delete. Before deletion, you have to check whether your queue is already empty or not. If it is already empty, then it is impossible to delete. Okay. See the code. First, return type is integer because the deleted element is an integer element. We have to return that element. So the return type is integer. It is the integer queue. All elements are integer. So the deleted element is also integer. So the return type is integer. Function name is QRemove. Here I am passing the address of the queue structure. Now call the function empty. We already learned how to write empty function. Passing the address of the queue structure, see here. If that function returns 1, means our queue is empty. Otherwise, it returns 0. If that function returns 1, then the queue is empty. Then it is impossible to delete any element from the queue because queue is empty. Otherwise, you have to collect that element pointed by the queue front because front is the deleting end. Okay. So q arrow item, q arrow front, and store that item to the variable y. I declare y here and return y here. Okay. So I repeat, that element, collect that element pointed by the q arrow front, and return that element. So q arrow item, q arrow front equals to y and return y. So y equals to q arrow item, q arrow front. Now if there is single element in the queue, after deletion there is no element in the queue, queue becomes empty. So how we can check whether there is a single element in the queue? If the value of rear and front are equal, then we can say that there is single element in the queue. So after deletion, your queue becomes empty. So make both rear and front as minus 1. I repeat, if there is a single element in the queue, then the value of front and rear are equal. After deletion, make both rear and front as minus 1 because your queue becomes empty. Now, otherwise, you have to increase front and delete the element, increase front. So, delete the element means take the element to the variable y, return y, and increase front. So, what is the formula? Formula is q arrow front equals to q arrow front plus 1 mod max. In this way, front will increase. Take the element, return that element, front will increase in this way. When it is max minus 1, then start deleting from the beginning of the queue. So this is the coding for QRemove. See the coding to implement primitive operations of circular queue. So this is our coding. Here value of max is 6. Yeah, we define one macro. So the value of max is 6. So our queue can hold maximum 6 elements. These are the function prototype. These 4 function empty, full, QInsert and QRemove. This is the basic structure of the queue. The array item which hold max number of elements. Max is here, max is 6, and rear and front 2 integer variable. This is the object of the queue. Initially make rear as minus 1 and also front as minus 1. Means we initialize rear as minus 1 and front also as minus 1. Now this is our index. Take the choice from the user. First one is QInsert, want to insert some element in the queue. Second is QRemove, want to remove some element from the queue. Third is exit, close the program, and fourth is default, that is the wrong key. Now take the choice from the user. Now this is our switch case control statement. Switch choice. If it is case 1, then first case is to insert some element in the queue. Then take the element which user want to insert. Okay, say the element is X. Now call the function QInsert by passing the address of the queue and the value which the user want to insert. Now call the function QInsert. Here the QInsert function is written. We already discussed about QInsert function. Send the address and the value. Check whether it is already full or not. If it is already full, then it is impossible to insert. Otherwise, insertion is done here. This logic is already discussed. So this is our QInsert function. Now it comes to second case. Second case is QRemove. Call the function QRemove by passing the address of the queue, and that function returns one element, the removed element or the deleted element, then print that deleted element here. So call the function QRemove. See here is our QRemove function. By passing the address of the queue, first check whether your queue is already empty or not. If it is already empty, then it is impossible to delete. Otherwise, removal is done here. This logic is already discussed. Now you have to write also the full function, because we call full function at the time of QInsert function, and also this empty function because we call empty function when we start this function QRemove. Before that you have to check whether your queue is already empty or not. So you have to write these two function also. Now third case is exit, that is close the program, because our I write this within this do while loop. It is an infinite loop while 1. So to close the program, you have to, there should be one case, that is case 3 exit 0, and case, the default case is wrong key, means if user is pressing 1 except 1 2 3 any other key. Now when we run the program, supply your choice. Say I am giving 1, supply the element for insertion 11, again 1, element for insertion 22, again 1, element for insertion 33. Now I want to remove. So which element will be removed first? Because it is queue, it follows FIFO rule. So first inserted element will be removed first. So first inserted element is 11. So when the choice is 2, the removed element is C, the removed element is 11. Again, when the choice is again 2, the removed element is 22. Now case 4, say pressing any wrong key, say 9. So it is wrong key. And case 3 is exit. So close your program. So in this way, circular queue works. Now I am showing the whole program. You have to done this program by your own in your laptop. So see the program. First these are this header file you should include. Then this is the prototype declaration. Then it comes to queue structure. This is queue structure. Then our main function, initialization of rear and front done here. Then this is our do while loop start. This is an infinite loop. These are our index. Take the choice. Then switch case control statement, switch choice, case 1, then case 2, case 3. Don't forget to write break here. Finally, while 1, this is infinite loop, complete do while loop, completion of do while loop, then get CHE end. After that, this is our empty function. This is our full function. This is QInsert function. And this is QRemove function. Now do it by your own. This is your programming assignment. Try to write this program to implement the primitive operations of circular queue by your own. So these are your homework. choose the correct option and answer me in the comment section what is the correct option. Pause this video, try to answer this question. I am waiting for your reply. For getting more and more updates, please subscribe my channel. That's all for today. Thank you.